Okay, still on relations and functions. So some type of functions, we have constant function, identity function, and absolute value function. So if we're going to graph this using GeoGebra, let's say if we have for a constant function y is equal to 2, so this is the result of our graph. Y is equal to 2. Okay, again y is equal to 2. So this is an example of a constant function. How about if we have the other example is on identity function, y is equal to x. We have y is equal to x. So this is an example of our function. The graph of the function y is equal to x is this one. So it is an increasing function. It started from left to right, so it is in an increasing function. Okay, another example, we have an absolute value function. Let's try to graph. What if we have function, where is this absolute value function here? Absolute value function, where are you? I cannot find the graph for absolute value function. Where is it? Absolute value of x plus 1 is equal to y. So this is an example of an absolute value function. Y is equal to x plus 1. Okay, some other functions, we have quadratic function. This is the quadratic function. Cubic function. And square root function. Okay, these are the different examples of functions. We also have the cube root function. So get familiar on the different functions, the graph of different functions. This is the cube root function, reciprocal function, and the reciprocal squared function. You can always give a try using GeoGebra. So for example, for cubic function, let's say we have cube root of x is equal to y, unknown command. cube root. Where's cube root? Hello. Okay, that's the graph of a cube root function. So this is cube root. Other examples, we have reciprocal, so 1 over x, the graph of 1 over x. Y is equal to 1 over x. X. So this is the graph. That's 1 over x. We have cube root function. We have absolute value function. What else? We also have reciprocal squared function. Let's try to graph using GeoGebra. So we have y is equal to, let's say we have 1 over x squared. So that's the graph. So this is the graph of 1 over x squared. Again, this is the graph of 1 over x squared. Okay, some other functions like the transcendental functions. Y is equal to sine x, y is equal to cosine x. You can give a try using your GeoGebra. Okay, let's try some skills exercise. How do we answer this kind of problem? Let's say, for example, we have question number 1. Okay, which of the following relations in the set of integers is a function? Now, in the given, we have paired numbers. 0 and 1, 0 and 0, 1 and 0, 2 and 0. Negative 1 and 0, 0 and 0, 0 and 1, 0 and 2. Okay, in order to be able to identify which of these paired numbers is or are functions, we have to consider the value of x or the domain. If the domain is repeated, it is not a function. Okay, let's take for example, letter A. Letter A, the domain or the value of x, we have 0, 0, 1, and 2. So, crush it out. It is not a function. Again, letter A is not a function. How about letter B? Negative 1, 0, 0, 0. So, again, it's not a function. X or the domain is repeated. The value of the domain is repeated. How about for letter C? Negative 1, 2, 1, and 2. So it's not repeated. How about letter D? Negative 1, 0, negative 2, 2. So it is not also repeated. So we have two functions. Negative 1, negative. We have letter C and letter D. They are functions because the domain is not. Okay, sorry. Letter C, the domain is repeated. You notice that we have this one. This is 2. and this is also 2. So it's not a function. So the only function here is letter D. -1, 0, -2, and 2. So our answer is letter D. X is not repeated. Repeated. Again, it is a function if x is not repeated. So if x is not repeated, it is not f. It is a function. About for number 2. It is a relation where each element in the domain is related to the only one value in the range by some rule. It is a relation where each element in the domain is related to only one element. So it is what? It is a function. About number 3, which of the following equations represent a function? So we have y squared is equal to x. It is quadratic function. So letter A is quadratic. Letter B is linear. Letter D is still a second degree equation. Let us try to graph letter D. X is equal to y squared plus 6. So we have x is equal to y squared plus 6. Is it a function or not a function? So using the vertical line test, again using the vertical line test, it represents a relation but not a function. So letter D is not a function. So letter D is not a function. And how about letter C? Is letter C a function? X squared plus y squared is equal to A. Is it a function? Let us try. Let's say we have x squared plus y squared is equal to A. It can be any number. So let's say 1 or let's say 4. Let's look at the graph. So the graph is, the graph is a circle. Using the vertical line test, we know for a fact that a circle is not a function. Okay? About number 4, question number 4. So in number 4, so we have here, using the vertical line test, so we will be able to identify which of this is not a function. Anyway, using the vertical line test, we will find out that letter D is not a function. A, B, and C are functions. Letter D is not a function. How about number 5? Which of the following is not a function? So in number 5, so this is one-to-one correspondence. Letter A is showing a one-to-one correspondence. About letter B. Letter B is many-to-one correspondence, as represented here. This is many-to-one. How about letter C? Letter C is still many-to-one. Letter C is many to 1. And letter D is 1 to many. So letter D is not a function.